Good evening. I welcome you all for today's session D flip-flop. So in the previous session we discussed about the types of flip-flops like SR flip-flop, JK flip-flop and T flip-flop, and also remaining two flip-flops are there. One is D flip-flop and another one is master slave flip-flop. In this session we are going to discuss about D flip-flop. So the D flip-flop is a modified form of SR flip-flop. D flip-flop is a modified form of SR flip-flop. The basic D flip-flop has a D data input and clock input and outputs Q and Q bar. See, the D flip-flop means it represents the direct flip-flop or data input flip-flop or delay flip-flop. So the main operation of D flip-flop is direct and delay. Whatever you give in the input, the same will be received in the output. This is all about D flip-flop. So this is the truth table of D flip-flop. So clock input 0 means your output may be 0 or 1. Your D output may be 0 or 1. So your output will be Qn, that is present state. There is no change in the next state. If our input is 1 and D input is 0, clock pulse is high. If our clock pulse is low, there won't be any change in the output. If our clock pulse is high, then if D input is 0, then present state next output will also be 0. If D input is 1, then output will also be 1. So, and we have discussed about the truth table. In this slide, we can see the symbol and circuit diagram of D flip-flop. So, the symbol is we are giving two input pulses or two inputs, like one is clock signal and another one is D input, and output is Q and Q bar. Q and Q bar or vice versa to each other. If your Q is 0, then your Q bar is 1, and if your Q is 1, then your Q bar will be 0. Now the circuit diagram, coming to circuit diagram, your input data, if you connect a buffer in your input data, then if your input is 1, then after the buffer you will get 0. Your input will be inverted. So the clock pulse and inverted input data is connected, and you have a common clock pulse here. So we have four NAND gates. We have four NAND gates. The inputs are D input and complement of D input, and one of your input excuse me the two input NAND gates, in each input, one of the inputs are connected together and a common clock pulse is given. And in remaining inputs, you are giving D input, and for another gate, we are giving the complement of D input, and both the circuits are connected with the cross-coupled circuits, with a cross-coupled circuit, that is SR latch, where you have a cross-coupled connection, like your few output is taken and given as a input. One output of a NAND gate is taken and given as an input to the another NAND gate. Okay. So next, characteristic table and equation of a D flip-flop. So Q 0 0 0 1 1 0 1 1, your output, whatever you give in D input, will be received in the output. So this is the characteristic table of D flip-flop, and with this table, by using K-map, we can derive the characteristic equation. Like by using K-map, we received a characteristic equation like Q of T plus 1 is equal to D. So this is the characteristic equation of a D flip-flop. So the working of D flip-flop is same whatever we said in the previous. Like this is the circuit diagram, and what else you give in the input, D input, the same will be received in the output. If your input is 0, your output Qn will also be 0. If your D input is 1, your output Q1 will also be 1. And the same working of D flip-flop, same table and circuit diagram. So the advantages of this D flip-flop is it simplify complex circuits, less chance of mistakes, intermediate state is eliminated. So the applications are data transfer. It is used in data transfer, counters, registers, and frequency divider circuits. So this is the excitation table of D flip-flop. So this is all about D flip-flop. Thank you.